So I was requested to do some problems from the homework in 5 for 1.5 questions 36, 40, and 44. And when I go there in the textbook, looks like these are 5. Looks like these um, are identity verification problems. So let's that. First one, number 36, is cosine theta over 1 minus tan theta plus sine theta over 1 minus cotangent of theta is equal to sine theta cotangent sine theta plus cosine theta. Okay, before we do this problem, I want to talk about trig identity. Identity is, in this sense, it's two things that look different but are always the same. So, like, for instance, x plus x, 2x is an algebraic identity. If I add something to itself, it's the same as multiplying the thing by 2. This is an algebraic identity. It is always true whenever we see x plus x in an equation, we can always replace that with 2x. The trig identities are the same thing, but for trig functions. And there are lots of trig identities. These arise from properties of the triangles that the trig identities are defined by. And just like x plus x is 2x, they are always true. And so when we're verifying these identities, we typically are pulling them back to identities that have proved earlier. This is always a good one. Pythagorean identity is sine squared x plus cosine squared x 1. So we want to try and rearrange the problem that we have into an identity that we know, or so that the two sides of the equation look the same. Usually we pick one side to manipulate and we leave the other side alone. This side looks like a simpler object. With these types of problems, it's usually easier to think of it as a simplifying process. So to start with a complicated side and simplify it until it looks like the simpler side. So I'm going to take the left-hand side. LHS is left-hand side. That's this side. And I'm going to try and do some simplification processes. And I'm done when what I have looks like the right-hand side over. So the first thing I'm going to do is there are lots of ways we could approach this. But I think that when I see the sum of two fractions, what I like to try is finding a common denominator and combining into one fraction. This is not necessarily the best way to do this, but it's the way that I want to do it. So I'm going to multiply the left fraction by 1 minus cotangent theta over itself. And the right fraction I'm going to multiply by 1 minus tangent theta. So, since I have two fractions where the numerators and denominators are equal, those two fractions are equal to 1. Multiplying by them doesn't change the value of anything. So I have not changed the value of the left-hand side, but I can now multiply the numerators and denominators together. So Let's do cosine times 1 is cosine theta. Sine times cotangent. Cotangent is cosine over sine. This becomes plus cosine squared theta over sine theta. The denominator we'll multiply out. We get 1 minus tangent theta minus cotangent theta plus cotangent times tangent is left fraction. I'll do the thing. I get sine theta minus sine times tangent gives us sine squared theta over theta. And then the denominator we're going to get the same as before. I'm going to do a little bit of simplifying. I'm going to add the 1 to the 1 minus theta minus cotangent. What I mean by I get the same thing, I have 1 minus theta here, here, and I have 1 minus cosine theta here and here. The point of the multiplications was to get a common denominator, so I'm going to end up with a denominator. I have this. I have the same denominator, so I can combine my fractions. I now have cosine theta sine squared theta over theta theta minus sine theta theta. Now, it sign back and look. Looks like this is negative, so that means this should be all over theta minus. I don't like compound fractions. If I multiply the top and bottom of this fraction by sine times sine, I'm going to get some cancellation. Try that. This is already starting to feel like it wasn't the right way to do it, but we can press on and see how this goes. I'm going to multiply by sine theta cosine theta over itself. I want to tell everyone that the best solution is the one you think up. The one you don't think up might be faster, but you don't think it up, so you don't know it. So right now I have this gut feeling like there's some trick I could have done earlier to make this go faster. But I didn't think of it in the moment. And maybe if I look back at this after we're done, I'll see it. But we're going to multiply these together to get rid of fractions. So we're going to get sine theta cosine squared theta minus sines cancel. I get cosine cubed theta plus sine squared theta cosine theta minus sine cubed theta. This is starting to look pretty bad. We get 2 theta cosine theta on the bottom. Sine theta cosine theta cancel. Plus sine theta minus theta minus theta. Okay, so don't have to delete anything. You can come back to this. This works out nicely. Let's try a different. Finding that common denominator didn't seem to work well. Let's try again. The original problem was cosine theta over 1 minus theta plus sine theta over 1 minus cotangent theta equals sine theta plus cosine theta. Now, I want to stress we're not going to delete anything because we might go down this rabbit hole and find out that it's worse and then want to come back. This is just how you do calculations. try something, get kind of stuck, you see if starting over, trying something else works better. So we look at this, and I think, well, tangent is sine over cosine. If I multiply this by cosine theta over itself, I might get something. So the left-hand side, what I'm starting with, I get cosine squared theta on top over cosine theta. The cosine is the sine, giving us minus sine theta. I'm going to do on this side, I'm going to multiply by sine theta over sine theta. Gives me plus sine squared theta over sine theta minus sine theta. Okay. This isn't too bad because this is just the negative of that. If I multiply by -1 over -1, I'm going to get cosine squared theta. Well, this is going to become negative sine squared theta, and then I'll switch the signs here, multiply. And then the two denominators match, so I can combine them into a common fraction. Cosine squared theta minus sine squared theta over cosine theta minus sine theta. This is really nice. The top is a difference of squares, so it factors as cosine theta plus sine theta times cosine theta minus sine theta. Bottom we have cosine theta minus sine theta. Those cancel. That leaves us with the right-hand side. So this is a complete solution to a problem. So I'm going to spin both my false start. I think it might be useful. But yeah, this is how I think you should approach doing these problems. You try doing some substitutions. If it gets kind of complicated, don't delete anything. Don't cross it out. Just maybe start over, see if you get something better. If you don't, you can always go back and continue what you were working on before. So that's 36. Let's look at 40. We have 1 over cosecant theta plus cotangent theta. And this is supposed to equal cosecant theta minus cotangent theta. So we want to pick a side that looks more complicated and simplify it into the less complicated. Looking at this, I'm going to pick the left-hand side. So the left-hand side, I have 1 over, now cosecant is 1 over sine theta. Cotangent is cosine theta over sine theta. If I multiply the numerator and denominator by sine theta, I don't change the value of my fraction, but I remove this compound fraction. I get sine theta on top. On the bottom, I'm going to get 1 plus cosine theta. I want to split this fraction apart. And I'm looking at this and I think a difference of squares might help me do that. If I multiply on the top and bottom by 1 minus cosine theta, it's going to give me sine theta minus sine theta cosine theta on top, and I have to figure out what to do about that later. On the bottom, I'm going to get 1 minus cosine squared theta. This is a version of the Pythagorean identity. Remember, sine squared theta plus cosine squared theta equals 1. Well, if I subtract cosine from both, sine squared theta, 1 minus cosine. That's what I have. 1 minus cosine theta. That becomes sine theta. I'm going to split the fraction up. Over sine squared theta minus sine theta cosine theta over sine squared theta. And that, I'm going to cancel a sign from the numerator and denominator. That gives me 1 over sine theta. minus, cancel a sign from the numerator denominator, cosine theta over sine theta, same as cosecant theta minus cotangent, which is the right hand. Okay. And there may be a slicker way to do that, but you look at it and maybe you find out steps you can cut if you want. But we got the solution. Number 44. We have 1 over 1 plus cosine theta is equal to cosecant squared theta minus cosecant theta cotangent theta. I'm going to start with the right-hand side. This looks a little bit more messy to me. The first thing I'm going to do is I'm going to factor out the cosecant. So 1 over cosecant theta, not 1 over, just cosecant of theta. I factor one of those out, cosecant theta minus cotangent theta. Okay. Let's try multiplying this by cosecant theta plus cotangent theta over itself. That gives us cosecant theta, cosecant squared theta minus cotangent theta over cosecant theta plus theta. Lines are blurring together there. 1 over, so cosecant is 1 over sine. I can pull this down as sine theta times cosecant theta plus theta. That's kind of promising because the next step, sine and the cosecant, sine and the cotangent will cosine. On the top, let's see, cosecant squared minus cotangent. Probably Pythagorean. We start with sine squared plus cosine squared equals 1. If we subtract the cosine to the other side, we get sine squared squared. Divide everything by sine squared. 1 equals cosecant squared minus cotangent squared. So yes, this is one of the Pythagorean identities. That's a 1. 1 times. Well, but we moved the denominator when we did that, so just have a 1 on the top. That's the left-hand side. Done. Okay, so those are the 3 problems that I was asked to do. I think that these trig identities are kind of fun. There's about being 2 different, showing the same, doing these trigonometry problems, and any more of them that you are having trouble. Okay. See you next time.